around 1/3 of patients suffering from epilepsy are drug resistant and need to undergo resective surgery. Despite many years of experience in these kind of surgeries, a significant proportion of these procedures are not successful. This is due to a number of reasons. One of them is that for many years it was thought that epilepsy was a local disease, meaning that it affects only a particular region of the brain that generates abnormal electrical activity that then propagates. However, recent studies show that epilepsy has what we can call a network component, meaning that it's not only a particular region of the brain that is affected, but also the way that different brain regions communicate with each other. This is one side of the coin, but on the other, communication in the brain is also a fundamental property. So, for example, now that you are listening to me, that you are looking at the way I gesture and so on, you are probably retrieving information that you have. You are trying to integrate all this information to understand what I'm saying. So this means that you have different parts of the brain communicating and cooperating to integrate all this information and to process it, and probably to respond accordingly, to decide whether you like what I'm saying or not, whether it's interesting or not. So whenever we are engaged in a cognitive task or we are performing a behavioral act, we have different parts of the brain cooperating to understand what's going on around us and to respond accordingly. So we know that communication is a fundamental property and capability of the brain, but still the mechanisms behind it are still poorly understood. So this is where my PhD comes into play, because I'm trying to understand the mechanisms behind this communication in the brain, and also what happens and under what conditions this communication can be disrupted. So what I do is to study brain activity with either fMRI or EEG. And I believe that this is key to understand how healthy brains function, but also the nature of what we call network-based diseases, like epilepsy, as I mentioned before. In my group, we have developed a measure that we call ignition, which measures the capability of different brain regions to drive or change the configuration of the brain. And preliminary results of my research show that this can be a good biomarker of the success of a surgery in epilepsy patients. And for the cases in which epilepsy is localized, so for the cases in which it affects only a particular part of the brain, I have developed an algorithm that allows us to localize the seizure focus in order to have a better pre-surgical diagnostic. So in the long run, I believe that this research will help us better understand how the brain functions, but also can result in better diagnostic tools and maybe even new treatments for epilepsy.